All right, we'll go ahead and kick things off. Do we have a scribe today or somebody who wants to volunteer to take notes?
I'll do it.
Awesome, thank you. And then do we have any new faces? Anybody who doesn't kind of show up to these regularly wants to introduce themselves? Don't think so. So we'll jump right into release planning and updates.
I guess I can give a quick update on the life cycle side. We're nearing the end of the issues that we wanted to tackle for this milestone. So yes, the one thing of note is that we're planning to ship a release candidate for this one. So keep an eye out for that. That's all.
Cool. And for PAC, yesterday during our platform sync, we decided that the next release will be on June 30th. And so because of that, we'll be going into feature complete next week. So if there's any changes, we want to get them in before that period.
Awesome. Any updates from other sub-teams, distribution or learning? Going once, going twice. Seems like no. Next thing is our weekly RFC reviews. Give me 1 second and I'll share my screen. All right. So the first one I just opened last night is kind of a stack pack alternative that removes the concept of stack. It's a little bit of a sweeping change. I think, Sam, did you put that on the, or someone put stack pack's alternative there?
I did put it on the agenda for later.
So I won't talk too much about it right now, but it does need labels. I don't even know what to label this. It's definitely at least implementation. Probably, oh, we have a core label, right? Two.
Yeah, you do one of those generally.
Yeah, that makes sense. And then spec labels. So it'd be all the specs. I think that's good enough. All right. And then add proposal for shared layers directory. This is Sam's. Where are we at this week? Looks like last thing was 15 days ago. Is it on the agenda? See it there. Sam, any updates on this one?
Not really. I think we had some discussions going. I don't know if so. I think last time we had some conversations around like different ways we wanted to achieve this, and maybe we want to go through that again today if we go through all the other agenda items.
Sounds good. Seems like we're still kind of in the design process, but it's not getting hung up. Cool. So I'll move on to the next one, and feel free to put that on the agenda at the end if you'd like. Make build layers read only for subsequent build packs. I think this one is on the agenda this week. So unless there's anything you want to talk about now, I'll move on to the next one. This is still blocked. I think Emily.
On the batch build pack, I actually just before this meeting put up a draft. I think for the batch build pack, it was most of the content, but it's not corralled into. I can't verify for the grammatical correctness of the sentences in there because I've not gone through it yet. And some sections are missing, but for anyone who's curious, I did put up a draft with most of the content in it.
Do you want to put that in the agenda? Is it worth chatting about
Sure.
now, or just because I'm really interested in that one.
Well,
My remove stacks one that I put together late last night is probably worse than what you did with Bash, so I wouldn't worry too much about it. All right. Next thing is disambiguate layer metadata from app metadata. Is this on the agenda too? I see SBOM RFC, but I don't see this one. So any updates here, Sam? Looks like we got a lot of approvals. Sorry.
Jesse took over this, and I think
Oh, right. We
this-
probably need a re-request on everyone unless they've reviewed since last week. I pushed up some changes. Or did I not push them up yet? I did not push them up. Okay, I will push them up. I made some changes. I need to commit them and push them up, and I'll re-request reviews from everybody.
Sounds good. I think I remember there being some, like Emily, maybe we talked about some concern in
Yeah.
changing some of these.
And I took care, or I at least took a stab at fixing that. So we'll see. I'll push it up and we can discuss it later.
Sounds good. Do you mean to just hit the re-request button on everybody?
It's not ready yet since I didn't push it up, so I'll do it. Don't worry about it.
Sounds good. And that concludes our RFC review. So next thing on the agenda is SBOM RFC. Sam, I'll let you take it from here.
still draft, but I've been thinking about it. Let me share my screen. So, couple of updates since the last time. Sophie and Forrest from the Paketo side helped me out with doing a comparison of the different current container scanning tools, what kind of outputs they generate in different BOM formats, how complete they are, what kind of fields they output, and how much time they take. I think they also put forward some conclusions from their initial testing. I think the parts at the left are trying out individual Cyclone DX scanning tools, which scan the source code instead of scanning the final image. But in general, if anyone wants to take a look, there's this repository that Sophie and Forrest put together around comparing what sort of metadata Pack currently outputs as a result of building the application using Paketo Buildpacks, what kind of metadata Sift, which is a container scanning tool that outputs in Cyclone DX format, does when run when it's scanning an image or when it's scanning the source code itself, and what Tone puts out, and Tone only has the container scanning mode. So those three are there, along with the average time it took for each of them to scan each image. So I think if you go in, you can see the actual time, which I think may also be a concern for us, because if we're doing this during build time, we do not want build times being affected a lot, where it's spending 2 minutes just on scanning and generating an SBOM. So that, and there were some interesting conclusions. So from the kind of fields that we are concerned with, as far as I can see, both Cyclone DX and SPDX have appropriate places to put data in. So there's this field comparison that was put together by them on where the existing fields that are used in Paketo are and how they map to the Cyclone DX and SPDX fields. Couple of things to note which are not here is Cyclone DX has this concept of a pedigree. So you can basically say that you took like a source distribution, which is what Paketo or Heroku often does, and you modify it slightly to have that Buildpack directory structure layout. So that's actually a concept that Cyclone DX has as a first-class thing, where you can define uh, in a library or a component or application which points to the original source URL, and then have another component and connect the two of them through this pedigree and say that, hey, there were no modifications. Like you can also specify what kind of modifications were made in the middle. So although currently it says that source URI and source SHA are external references, which you can't put it there, but I think this might be another better way of specifying like these kind of modifications we often have to make when we are shipping tarballs in Buildpacks format. The other thing to note is CPEs. So Cyclone DX can only accommodate one CPE field, whereas SPDX has this thing called package external reference, which is just like a list of external references. You can put different kind of references there, like security references or package URLs. And you can put any number of CPEs, package URLs, SH with tags and other things.
What does CPE mean? What do the three letters mean?
It's component. I'm
think
forgetting it.
it's,
Basically, sorry.
It's a common platform enumeration. It's like a notation, I think.
Okay,
So
thank you.
it's some way that NVD uses to identify like packages which are like it's another alternative way of specifying like here's the package version, the hardware tag, the distribution tag, etc., and like which ones are deprecated. So that database is maintained by NVD. And there are two other formats. One is PRL or Perl, which there was again some discussion about in the RFC itself at the bottom. And there's this other one which is
SWID.
and software historical. There's also SWIG. I don't know what that is. But they're also another way of identifying like the package version plus any modifiers. And the security scanning tools typically map these tags to versions that are affected. And yeah, so with CPEs, you can have like it has a lot of fields and some of them can be marked as wildcards. So when you're generating like a CPE for something like a node package, you can have like different alternative CPEs for the same package. That's why you might have multiple component CPEs. This can also be noisy at times when like you've put like a lot of fuzzy matching logic in there and your scanner then matches against it. But it might also catch up things which you might otherwise miss if the scanner doesn't have information about a particular CPE that you've specified.
Forgive my naivete here, but if the point is to take a very specific version of very specific software and compare it against a database to figure out, what CVEs it has, what is the point of having multiples or sort of fuzzy matching ones? Don't you want to be uniquely identifying something?
It's because sometimes you can have CVs that match like a range of things. So like the bug was in a source distribution and then you packaged it for different architectures and different operating systems and all of them have the same bug. So that's when you want like some wildcards to say all of these things are affected.
I could see that in being like when you're describing what's affected, when you're describing like this is what it is. Is there a case for a wild card there?
As far as I can understand from reading Swift's own discussion about this, it's actually a case of like they generate all the CPEs based on information they can glean from the package, and then they play like their own internal confidence game in terms of which one is the most relevant one, and then they try and sort them based on that, but they hand back all of them so that they don't just make it completely opaque. So like I think there's an issue recently that they filed that was like, we'll sort the one that we're most confident in to the top, but we are going to return all of them so that we aren't dumping data out, basically.
Yeah. So it, rather than most confident, I think it was most specific. So like they take the most specific one out first, and then they have like alternative versions of them where they just put wildcards everywhere. So that's what the CPE thing is. And interesting thing to note is Cyclone DX has marked this as deprecated, with it being marked for removal in sometime in the future in one of their specifications, but I don't know when. Patrick, who's one of the core team members of Cyclone DX, commented here saying that NVD will deprecate CPs at sometime in the future and replace them with SWIT tags. And the other interesting thing to note is SPDX itself recently added support for Perl in 2.2. So again, this is another aspect of it. Like, apart from the SBOM format itself, the unique identifier that's used is also something we may have to consider. Anyway, the what I have currently put here is this. So I propose that we pull out the SBOM into a separate file, which sort of mirrors the layer toml, launch toml, and build toml. So you'll have a layer.bom.cdx or JSON launch.bom.cdx and so on and so forth. This is simply because a lot of these SBOM documents need to be in a certain format, and we cannot put them in that exact same format in these toml files unless we want to create a mapping between the metadata table there to the original SBOM document. And the idea would be that the Buildpack would generate these documents, and the lifecycle would be responsible for taking all of them, merging them, and then storing them in some appropriate place. Originally, I included the fact that all of this metadata should be moved from a label to a file, but from the last working group meeting, it was suggested that that should be a separate RFC, which should be sibling to this one and should be implemented at the same time, but they're separate concerns. So, yeah.
Sorry, is there a restriction on how large a label can be right now? I know that we talked about that last time, but I cannot remember.
There's no restriction, but there are reasons not to have large labels, because when they get too big, it can cause bugs on Kubernetes nodes. Like when I think the kubelet is asking container D for the list of all the containers. It's using gRPC, and there's a message size limit. And if you have a bunch of containers with really big labels, you can take down your node.
So it might be more of a concern. You should definitely, at least with some of the apps that we scanned, some of the larger apps, like the Maven app that we scanned for the sample repo, that file alone is something like Cyclone DX is something like 42,000 lines.
Yeah, like I think some of the other stuff that we've stuffed into labels already is like 400K or something like that, and we know that that already causes problems.
So I'd just throw that out there in terms of it's not a problem for me. but it is probably a problem for anyone who's trying to shove this into a platform.
Like,
Yeah, like
maybe
I
it should
think
be
we're
a separate
committed.
RFC, but we probably can't do both because the bomb's going to get a lot. I mean, we have to do both. If the bomb gets a lot bigger because we move to this format, we also need to solve the label size problem, right?
Yeah, and that's the whole thing that Sam was saying. We're committed to doing that, to moving it back to a file, just not as part of this RFC.
And in terms of the alternatives, I've put two options here. One is like support SPDX instead of CycloneDX. The main reason being that it is again a Linux Foundation project, and there are people who are pushing for it to become the standard, and it is trying to invest a lot into like tooling itself and like filling in the gaps where like, because SPDX was originally meant to be used for more compliance use cases, it does license scanning and storing metadata about licenses better than it does about provenance and security scanning and supply chain analysis. So I think SPDX is trying to catch up there, and I don't know if CycloneDX will want to like fulfill the other side of the thing, where they currently do have a licenses field, but like SPDX has things like declared license versus what the inferred license was, or like license comments from each of the files, etc. The other thing that I've proposed here is to make this entirely agnostic to the lifecycle. So the only reason the lifecycle has to currently be aware of the SBOM format is because it's responsible for merging them, and it cannot merge them without knowing what kind of specification the SBOM is in. Now, if all the lifecycle was doing was simply taking those files that the Buildpack has generated and putting them in a specific place without worrying about their contents, we could just change the entire SBOM format in the future if we wanted to, and the lifecycle wouldn't have to change. So in this case, the responsibility falls on the platform, or like something like Pack, to take these individual files, merge them together, and produce an output in whatever format is required. And this merging and pulling things from the image could be like a library or CLI that's provided alongside Pack, so that other platforms can also reuse this. So
Like,
that
what
was
does
the
that gain, right? Like, you still have, you're like, at that point, having to exfiltrate a bunch of files out of the build containers themselves, all sitting around for a while, which then need to be merged and then be re-infiltrated in before the export happens, right?
So the idea was it would not be stored in the image. Like the final merge bomb will not be stored in the image. Just the individual files would be. And then if you want the final bomb out, you can just use Pack or this CLI or library to take the Buildpack generated image and then create the merge file. Because a lot of the times you would probably want this SBOM maybe elsewhere, like in this last discussion with Dan, they were thinking about putting the SBOM as a separate OCI artifact. Or you might also want to extract this bomb and put it into a separate database that's used by a scanner. So
yeah, but even for us though, like, suppose we don't do the label, right? And suppose we go with that thing where it's going to be just a file on a special layer in a special place, right? Like, that requires us to re-infiltrate that file after the merge is done if we try and do the merge externally.
Re-infiltrate? What do you mean? So like, wouldn't it just read the list of files and generate the output?
So it needs to go, so like after the build containers run and you've got a bunch of, or the build container runs, and you've got a bunch of stuff on layers, right? You've got a bunch of these layer things. if the life cycle isn't responsible, I mean, hell, even if the life cycle is responsible, you got to pull all of that data out, merge it into a single file, put it back into somewhere so that the exporter then runs against that same thing, right? Because if it needs to be an artifact in a layer, it has to have been created and put back onto the file system in the right place before the exporter is run.
So I'm saying that it won't be a part of the final, like the merge bomb won't be a part of the final image. It won't be exported via the exporter. It's just something that can be reconstructed reproducibly by the platform given a image built by Buildpacks.
Yeah, like I don't love that. Like forcing every downstream user to know all of the different places to go look for these files so that it can merge them and come up with the answer. Like that, the fact that we've chosen to do this incrementally doesn't feel like a thing that we should be projecting downstream.
I think I agree that it would be better if it was, you know, 1 or 2 requests to get the SBOM. Like, you know, I think I lean that way, but our client is already going to be pretty complex because it's got to look up a manifest and then look up a config blob and then find a, you know, label that points to a blob and then download the blob. You know, it may not be that different if we have strong reasons for keeping it separate. We're already going to have a specific and complex client for constructing this, and so the, you know, I don't know if it makes a huge difference in, you know, realistically for how people are going to do it. I'd be interested in hearing what the benefits of keeping it separate are, aside from just keeping the like runtime one and the build time one separate.
So the reason, like separate as in like, why not merge it in the lifecycle and keep it in the platform? The only reason was like currently one of the things that I've proposed here is, since this whole SBOM conversation is still up in the air, people might want different formats, right? They might want an SPDX formatted version, or in the future something else comes up, and they might want that. No.
But like I don't think you can actually make that as portable as you want it to be, right? You'd have to convert like in lockstep. Every single one of your build packs would now have to be putting out a new set of data, and your, you know, pulling all of these things off the file system and merging them would also have to have changed in lockstep. And like, I can't see that as a possibility. I think we're better off basically making the lifecycle aware of everything it could be, and then somehow normalizing that into whatever it thinks the internals should be. Otherwise, it's totally not dependable, right? Like, suppose you're a downstream client trying to use this data. If you can't depend on it being in one of these formats, like, what are we even doing here, right? Like, we might as well write our own YAML format at that point, because they don't know when they look at it, is it going to be SPDX? Is it going to be Cyclone? Like, I don't know.
Especially if you have a group of build packs that are making different decisions, and then you got to merge them together. That makes for a very complex client.
The only reason I put in this alternative was like, there was some concerns around introducing this as like a first class thing in the life cycle, like whether we want to stick with one SBOM format and like have to support it forever, essentially.
But it's, I mean, like, I think we should, right? Like, this is actually a promotion of the idea of an SBOM to a first-class construct inside of the Cloud Native Buildpacks project. To date, all of sort of the BOM stuff that we've done have been just sort of like, whatever, you can fill it in, you can not fill it in. There might be enough information to go figure out what your CVEs are, maybe not, who knows? But we're saying this is a valuable thing. This should be a first-class construct of a standardized SBOM in Cloud Native Buildpacks, which I think puts it on the table that we should have first-class support inside the lifecycle for it. As far as supporting it forever, like, yeah, okay. But like, if we want to make a change at some point in the future and we want to switch from A to B, the lifecycle already has all the code for A. It can just hold them for whatever we think the length of the compatibility and the standard is, while also adding B, making sure to convert them to whatever the canonical representation is inside of the build pack at any given time, or inside of the project at any given time. And then we eventually drop support for A, you know, when you go to CNB 2.0.
Yeah, that was the only question. Like, do we want to go through all of that effort, or should we just keep it in? Like, should we just move all of that complexity to the platform, which is easier because there are more platforms than there are lifecycle implementation, so people can still choose. Like, if they
It lowers compatibility though. Like that's fundamentally my argument about it is, okay, great. We now have made um, SBOMs a first-class construct inside of cloud native build packs, and you have no idea what format a build pack is going to provide to you. So good luck. You actually need to write support for all 3 to 5 different versions. And if we're going to write the library to help them with that, then we might as well just write it into the lifecycle, right? The fact that you're always going to have both the latest version of the lifecycle and the latest version of this library that knows how to read all those things. I mean, we just now have 2 binaries instead of 1 binary, both of which we have to have complete control over.
Well, I mean, lifecycle itself is complex. Taking a few files and parsing the SBOM and putting them together is not as complex as the things that the lifecycle currently does. That was the only other like argument for keeping this separate in a separate binary. But yeah, at this point, like
we used to have, or like we do have 5 binaries, and yet everybody uses creator.
Thinking about, sorry, thinking about that ability to like switch between different formats, right? We're talking about migrating the build packs over to produce to different formats anyways. Like I could see an argument for like the format on the image in the end, being allowed to be in some fixed number of formats, and you can look at the name, and then, and I think there are disadvantages to that, but because no format has really won yet, maybe that makes sense. But having the build packs all output a different format where you don't get, there's no consistency even within one image between all the metadata in the end, that seems pretty risky. Am I thinking about that right? I guess.
Yeah, but I was imagining this as more like we would, like, the life cycle would just verify a couple of things. It would verify that here's a list of formats that it accepts. So the extension at the end, like spdx.json or cdx.json, is the only thing it has to check. It wouldn't worry about the contents themselves. And then those are like the sort of 2 options that a build pack can choose to provide things in, and we have good tools to convert between either of them and merge them together. So
I see.
The other option can be that we can also move this whole logic inside of the lifecycle itself and provide that as a option to build pack owners. But my idea was, right now we say that these are the 2 supported formats. Pack would initially only implement support for Cyclone DX. So the build pack authors would obviously have more of an incentive to write them in Cyclone DX format. And then in the future, if push comes to shove and then SPDX is the leading format, we don't have to go through this whole migration. We could simply add like support for SPDX in that other binary. And there are already tools for converting and like mapping the fields between the 2. So it wouldn't be that bad. But again, it's more of what we decide to do rather than like whether we want to put more complexity into the lifecycle, whether we find that it's worth it providing build pack authors the flexibility between 2 different BOM formats, whether it's again worth it providing conversion tools as first class citizens in pack. And then if you're providing conversion tools, why not just also provide the merge tool within pack?
If we need to do a migration to SPDX later, I agree that if build packs could output SPDX now, there would be a less work for build packs that chose to do that, right? But I think we could provide that tool if we really need to do that migration, we could add that functionality later Buildpacks could have as much time as they want to convert over, because it'll always be possible to convert anything that's in Cyclone to SPDX before merging it together. So like, it seems like we can get that migration, you know, and add that complexity later if we need to, but maybe for now it'd be easier just to start with one format and try to get the standardization.
Okay, so, and in terms of putting it in the life cycle, that's something we do want to do, like, because I don't want to write an RFC where I'm describing a bunch of these things where then the life cycle is not really responsible for it, and it's just a platform concern or something else that can do it as a post-processing step.
I'd say the life cycle should merge it together. But it's just my take.
That's it. I think we also have like an office hours later today where we can ask more of these questions. But yeah, we can move on to the next topic.
I had a question going back to the CPE versus Perl and the different fields between the two formats. So the first thing I'm wondering about is, it seemed like Cyclone only let you specify one or the other between those two, or is there a standardized way of specifying both Perl and CPE?
So Cyclone DX allows you to specify all three of them, SWID, Perl, and CPE. The only issue is that it only allows one CPE as opposed to a list of CPEs.
Okay, so it wasn't one field for external references. Okay, that makes sense. And in the SPDX case, you can have as many references as you want, but you have to dump all the CPE, Perl, and all that into the same kind of group. Is that right? Makes sense.
So the thing with Perl and SWID is they are unique identifiers. So ideally, there can only be one of them to uniquely identify one package. So if you have multiple Perl fields, you're probably doing something wrong there.
That makes sense. It's interesting that they only allow one in Cyclone, but
CPE.
Yeah.
It was the same argument that Emily gave, that you should have like the most like pinpointed version of it to match against, rather than giving false negatives. But there are other issues with like how good the data is. So
CPE is also a query format. It's like how you search NVD is through the CPE wildcards, and then people started using the wildcards in the CPE, so it's all a mess now. But that makes sense. Okay, that's all I had. Thanks. Should we move on to next thing on the agenda? Is StackPack's alternative. So that's mine. I guess Sam, you put that up there. So did you have specific questions you want to lead with? I was going to leave it up for a little bit first, but I'm happy to talk about it here too.
I had a couple of like questions on like so maybe you can just go over it, like do a quick overview, and then I can ask questions.
So it's a little rough, and I was gonna kind of leave it up for a couple days, maybe for a week before presenting it before, but I think it's probably good to just get as much feedback as possible. So I'm happy to talk about it here. The idea here is, we've been talking about StackPacks and the complexity StackPacks add. We've also been talking about kind of general complexity in the project. And I've had a lot of conversations with folks who feel like a lot of the terminology in the project kind of makes it hard to understand how things work, because we don't always use the terms that the rest of the ecosystem uses to describe concepts that are very similar, right? Like stacks versus base images, for example, or what are mixins. And so this kind of gets rid of everything at that stack level and replaces it with well-known constructs in the ecosystem like base images and Docker files and OS package references, and also merges that with the bill of materials stuff, at least more more so than it is now. So basically, the summary is we replace mixins with CycloneDX formatted list of packages. That's it. Run image and build image both have CycloneDX formatted list of packages on them. It's also the SBOM. The label for those is IO Buildpacks SBOM. Like if you look at the base image, it just looks like we took a regular Docker base image and put, you know, a list of packages on it. I think this would use your RFC to move it to a different file also. Sorry, go ahead.
By CycloneDX formatted list of packages, do you mean like using Perl or like?
Yeah, it's in there also. It uses a Perl. You put a Perl URL into it's down here into whatever entry is appropriate in CycloneDX for doing that. So you have a reference to them. Then it replaces stack packs. This says it replaces stack packs with build and run Docker files. It's actually replacing stack packs with two things. One is the app developer can use like a run.docker file and a build.docker file to extend the image before the build happens, extend the build image and the run image before the build happens. But it also introduces an idea that I think Ozzy brought up a couple months ago, where you can have multiple run images in a builder, and the kind of smallest run image would get selected automatically based on packages the Buildpacks request. And then it also just replaces the idea of a stack with just kind of very standardized, canonicalized OS metadata stuff. So I'll kind of go over those things one by one. You know, on that last thing I mentioned, right, stack goes away and instead you get, you know, Go OS, Go Arch, and then the ID and version ID from, you know, like OS release, right? So like Ubuntu 18.04, for instance. You know, this is what's used to match for stack IDs. These always have to match, but if you're doing like a rebase, or if you're building with a different, you know, custom run image, you can pass -- force to either pack build or pack rebase, and you know, these things don't have to match anymore. So all the ABI compatibility enforcement is overridable and is kind of lighter weight than it was before. You know, we take the OS package information out of Buildpack TOML, and during the detect phase, Buildpacks can express what packages they depend on in, I think, in Perl format. You know, so we get rid of mixins entirely. Mixins would no longer be validated between the run and the build image. So you can use any run image and any build image you want, but if you try to rebase with a run image that has fewer packages, then you have to pass -- force to pack rebase. So you can't, so there's like a little bit of protection against, you know, doing something that's unsafe in that case. You know, this is like Ozzy's idea, like I mentioned before, we would, during detect, Buildpacks can output a list of packages. When you build a builder, you can specify not just run image and run image mirrors, but a list of run image mirrors combinations in order. And the first one that meets all the requirements, that like matches all the packages the Buildpacks output, is used. The packages are output during detect instead of at the end of build, so that the build image and the run image can be, so that the run image, just the run image in this case, can be extended while the Buildpack build process is happening in parallel if you wanted to, if a platform wanted to put a lot of effort into making it really fast. And then this is, you know, kind of the replacement for like stack packs plus, you know, specifying packages in Project TOML would just be a build Docker file and a run Docker file in the app directory, but these would also be the same Docker files that you would use to create a new stack or to extend an existing stack. The format would be the same. You could reuse Docker files from different contexts to do those different things if you wanted to. So if you had your app with Docker files in it, you wanted to build a custom stack, instead of doing that on it, you know, directly on build, you could, you know, reuse them in the same context. They're basically, you know, Docker files with the, you know, parameterized from and just a special build ID flag. So if you ever wanted to like ensure that every build gets a, you know, rebuilds from scratch or rebuilds from a certain point, you can use the build ID to, create a different instruction as a cache busting mechanism. And there's a special label you can add that will make rebase require -- force to be passed to pack rebase for it to work if you're making changes in your run image that aren't ABI compatible. And so we still give that, compatibility guarantee, compatibility guarantee there, but it's overridable. And as the author of the Docker file, you can choose whether or not it's unsafe. Yep, it's a lot and probably needs more detail, but that's basically the idea.
So I have a question or maybe concern about replacing mixins or getting rid of mixins altogether. I think, well, for one, right, like how difficult would it be for the stack authors and I guess Buildpack authors to kind of contract out based on Cyclone DX, bomb notation?
Yep. So there's something I left out, which is when you're creating a stack, it's in here. Thought I had an example that did a copy. Yeah, here you go. When you're creating a stack, you have to provide some code that understands how to parse the stack's package database or whatever determines the packages that go into the stack and output that Cyclone DX formatted list of packages with Perl. This is something we could provide as part of the project for Ubuntu, UBI, whatever. But this would automatically get rerun anytime a stack is extended. And that way you write your Docker file, you can install packages like this and your, whatever, and you don't have to worry about generating a list of mixins or a list of packages or anything. The stack author is responsible for providing code on the stack. Again, the project could create this logic, but when you create a stack, if you want it to always keep its metadata up to date, you have to copy that into the stack image. And so the idea that's how we solve the, keeping a consistent list of formatted things up to date that's distribution specific.
And then I guess the other part of that, right, for me was, would there still be a use case for mixins? Because, I know that we've talked about mixins a lot in regards to OS dependencies and packages, but I feel like there was a superset of functionality, which was just that you could add attributions that then made it to match very specific things. And so I do wonder if there's other things that aren't part of the SBOM, right, that could be useful to still keep mixins.
So it's a Cyclone DX formatted list with Perl IDs, but nothing says that they have to be packages that match that distribution. And so if you added other things to the stack, you could add other entries to the Cyclone DX formatted list that have, as long as you can come up with a Perl, thing that uniquely identifies it. Perl has some generic fields to it. So you can, it's like you're not limited to NPM packages or deb files or whatever, there's a generic key. So you could add things to that list that aren't Ubuntu packages and then expect things to match against it if you wanted to. There's that flexibility. But it's just the format that's defined and the globally unique ID that's defined.
I had a
Sorry,
question.
Anthony has his hand raised.
Oh, just want to make sure, if the other topic was we're ready to move on from that. I just had a simple one about the app run Docker file. I guess I'm just having trouble seeing what component runs that, right? Like, is it up to the platforms? Like, is it literally up to Pack to run that?
So the lifecycle would handle, using the Docker files to extend the base images in the different contexts. Lifecycle, when you're using a build kit front end, would probably use build kit to do it. When you're on a platform that doesn't have a daemon or build kit, would probably use Conoco to do it, right? Depending on your build strategy, you could do it different ways. So it'd be a new phase in the lifecycle. This doesn't go into implementation too much, but I wanted to keep it kind of higher level. But I imagine there's another phase that happens like before export that generates a run image, and then there's probably another phase before detect that extends the build image, and in the creator case, you're probably gonna like use Conoco to run the Docker file against the build image live before you start the build, so you don't have to have another phase there. There's a lot of it's some parts, but only the starting parts of the complexity of what we talked about for stack packs, if that makes sense. Hopefully it doesn't create the more interesting combinatorial problems, I think, we came up with the stack pack proposal.
So this would be for rebase and something like a stackify operation, is that?
Sorry, what would be for rebase?
So like these Docker files, right? So these Docker files, are they creating the initial version of the stack itself as well?
These Docker files can be used. So you can use a build Docker file, run Docker file, but that format of Docker file can be used to make a new stack, to extend an existing stack, both outside of a build, right? Or during a app build, they can run immediately, before and or during the build in order to create the image. They never run during rebase. Rebase either fails if you have this label with the ability to override the failure and just do it anyways, or it just works if you don't have the label and rebases that base image out from under the Docker file.
Okay. So this flag is kind of baked into the stack at creation time and not something that is trying to happen during the rebase operation. I might just have to look more into it. I feel like my question might not be fully formatted.
I had a question on how this. So I get that stacks are not providing polls to specify that they have these packages. How would, like, whatever the equivalent here is, like you have a build pack that requires certain packages. It requests them. If it can't satisfy them as it is, how does it take that poll and convert it into a format so that it can install those dependencies? So like, how the other one had star mixins where you could just say, like the build pack could say, I require everything, and the stack pack could say, I provide star, and then it could just install like all the appropriate packages.
It doesn't have the functionality to install additional packages using that mechanism. It only has the ability to, given the list of, so I don't really, not very attached to this format, but currently the build packs output Perl URLs without the version or qualifiers because they're optional in the Perl format, although it's kind of using Perl for querying, which is not great, but I couldn't think of a better alternative for matching. But it makes a big list of those from all the build packs, and then it just runs through the list of run images and picks the first one where they're all satisfied. And if none of them are satisfied, then it just fails the build. It doesn't install them. There's no functionality for build packs to install packages during a build anymore in this proposal. It cuts that out because I think that's what led to most of the complexity of the stack pack proposal. It lets you have different sized run images, and it'll pick the one that's suitable. And as an app developer, if you need a package for your application, you can use a Docker file to install it.
So let's say for whatever reason you have like a Java build pack, a Python build pack, and like a Node build pack, and you have this whole thing packaged together in the builder. Now, if you go through this way, your run images or your build images would have to have a combination of all of these, right? If you want the most minimal run image, you would have to accommodate each of those combinations, right?
If you create a minimal run image that doesn't have those combinations, then it's not going to be selected during that build. But you have to have at least one run image that meets all the possible package combinations in order to support builds that require that combination of packages.
So in
So then it won't be the minimal anymore, right? So I can imagine you would create like a scratch image, let's say for Go. Then if you want to add Java, you put one with libc in it or whatever. If you want to add Python, you put one with libc and like all the other basic Python dependencies. But then if you want to support like just Python and Go or like some other language, but not support Java, you can't. You would have to accommodate each and every one of those combinations if you want a minimal image. Otherwise, you just put this huge image with all of the base dependencies, and that's the one that gets satisfied, right?
That's correct. You have to, if you want to get every possible minimal combination of every combination of the languages selected, then you have to supply, if you and you want it to be a minimal image in all those cases, then you have to supply every combinatorial version of that. So instead, I imagine people would create a run image for each of the languages, and then maybe one really big one at the end. So when you're using multiple things together, you don't get a minimal image. You get one has pretty wide support. But there's an alternative to this, which I think is really like, this was so you could support like a builder that has a lot of languages on it, that has some different, run image options. I think the real alternative is have the app developer specify packages they need for their very custom application in a Docker file instead, because the Docker file will run first. It'll extend the thing with the packages that are on there, and then during the run image selection process, it can select the more minimal one that includes the stuff that the app developer added. And so the app developer can use a run Docker file and a build Docker file in order to create a more minimal image in the end. But it doesn't require.
When someone's providing this Docker file and there's multiple run images, we're not going to extend them all, right? I'm not quite sure how these two things fit together.
So the run after detect runs, I see we're at time. After detect runs, it outputs a list of packages, then a run image is selected, and then that run image is used as an input into the build and run Docker files at the end. And so then, yeah, that means that if there were a lot of requirements, so I don't think you could use this to generate a perfectly minimal base image because the run image will be selected before the run and build Docker files are selected. So we could come up with something else that would let you, maybe run this before detect on a more minimal one if you wanted to. I agree. They don't work together in lockstep. The intent was more different, different use cases for solving different problems.
The only reason I don't like the app developer specifying all of this is we break our most essential contract, like where the app developer does not have to know about, like, this is one of the most basic things, right? Providing dependencies for the Buildpack themselves to run. Now,
we park this for a working group because I'm late, but I care a lot about this conversation.
All right. Well,
I mean, office hours.